If dt is 60, so they tell me that this whole thing is 60, determine the value of x, determine the value of ds, and determine the value of st. So again, you have to do the 2 steps of geometry. What's the relationship between the figure? Well, because it's a segment with 3 points and one's in between the other two, I know then that this segment ds plus this segment st is equal to this segment dt. Well, how do you know that? Well, that's because the segment addition postulate says so. Again, this is the geometry part of the course. If you skip this, then you're not doing geometry. Now that you have geometry, you can go ahead and substitute in these values. So what is ds? 2x minus 8. What is st? 3x plus 12. What is dt? 60. So now that I've substituted all these in, I now have an algebraic expression which allows me to determine the value of the variable using my algebra skills. I'm no longer in geometry, I'm now in algebra. So that's just showing you how I substituted those in. So solving this, I get x is equal to 16. Now again, a lot of students will want to stop right here. That's only part of the problem. Determine the value of x. I also have to determine the value of ds and st. Once I have the value of x, I can go ahead and substitute those in. So I determined that x is 16. I know that ds is equal to 2x minus 8, so I just go ahead and substitute this 16 in for x, and then I can go ahead and determine the value of ds, which is 24. Then I can put the 16 in over here, whoops, and I can figure out the value of st is 36. Now I started off by saying, if we go back to the previous page, that ds plus st is equal to dt, which means if I add these two together, I should get dt. And I already know that dt is 60. So if I add 34 and I add, 24 and 36, I should get 60. 60 equals 60, so I'm able to check and see that my answer is correct. Okay, so again, make sure that you use the values of the variables. You use your geometry to write the equation and then determine the value of the variable and answer the question. So here's a problem for you. I'd like you to go ahead and stop the video, write everything out, and then when you come back, I'll walk you through it and see if you get all 4 steps taken care of. Okay, geometry step number 1 is what's the relationship? Well, I see a line, a point between it, so I know the 2 parts equals the whole part. So I need to write my geometric expression first. So I know that EF plus FG is going to equal EG. Well, how do you know that, Mr. Godfrey? Well, because of the segment addition postulate. The segment addition postulate says that those parts would be equal. That's the geometry. So now we could stop there, but we're going to go ahead and determine the value of x. Now that I have this, I can go ahead and put in these algebraic expressions. So EF is what? 4x minus 20. So I can put it in 4x minus 20 for this EF plus FG, which is 2x plus 30, and that equals EG, which is 100. So now I can go ahead and use my algebra skills to simplify this. So this is 4x minus 20 plus 2x plus 30 equals 100. That's using the distributive property to remove the value, or to remove the parentheses. I can add like terms here then. So I have 6x plus 10 is equal to 100. I want to get this variable by itself. So, 6x is equal to 90. So x is equal to 15. So I have the value of x. The value of x is 15. Oh, I have more to do. Determine the value or the length of EF and FG. Alright, so I go back up here. EF is equal to 4 times x, which I now know is 15, minus 20. So EF is 4 times 15 is 60 minus 20, so that is equal to 40. Okay, so I have answered that part, and now FG. What is FG? Well, FG, it says here, is equal to 2 times my x value plus 30. So FG is equal to 30 plus 30, which is 60. Now, how can I check my work? Well, we started off by saying that these two added together is equal to this. These two added together is equal to 100. So 60 plus 40, does that equal 100? Yes. So I'm pretty sure my answer is correct. All right. So that would be the type of work that you would be expected to do in determining the value of x and these lengths. Again, one final time, and you'll hear me pound this all year long. This is geometry right here. Understanding the relationship and writing the mathematical expression that describes it, and then giving the reason. Everything else is all algebra. So if you're just jumping to the answer, you're skipping the geometry part of the course. All right? So keep working, and we'll see you in class.